In this next section, 3.4, what we're going to be taking a look at are two separate issues. They're kind of related, but they're essentially separate. The first one is this idea of a piecewise function, and then the second issue will be we're going to review our basic functions. I think we actually took a look at this when we were graphing in Chapter 1 or earlier in Chapter 2, but now that we're talking about functions, we'll kind of put that all together and get ready for 3.5. But let's go ahead and address the idea of piecewise functions first, and then we'll build from there. So to understand a piecewise function, right, I'd like you to kind of think of a real-life situation where the rule we use for the function, remember functions are rules, right, but the rule changes depending on the input given. So let me pause for a moment and let you kind of think. Can you think of any real-life situations that you have probably dealt with where the input given drives the function rule that we have? All right, and there's two examples off the top of my head, and one might be your data usage. I'm going to age myself a little bit, but I do think it still kind of goes in this manner. But you know, we pay for. I mean, you got obviously there's some plans that are unlimited data usage, right? So that way you just pay a flat fee, and that rule doesn't change forever, right? But there's some things where you know you basically have, let's say, a dollar amount and data used, right? But maybe you only have 15 G of data, and so you pay like a flat rate. Let's say it's $20 just to throw something there. So for 15 gigs of data, you're going to pay a flat rate of $20. However, when you get past that, what they'll do is they'll charge you for it. They'll either make you get another plan and charge you, or they'll charge you by the gig or whatever the case might be. So we have what's called an open circle at this point, because when X equals 15 gig, they're now going to charge me a little bit more. Let's say it's 30. And then let's say they're really mean and they start charging me actually not a flat rate for those gigs past 15, but there's actually some sort of rate. Maybe it's $1, maybe it's a half cent, something. And so what you have here is the rule changes, right? It's equal to 20 as long as we stay between 0 and 15 with regard to my domain. But as soon as I get past 15, and let's just say go to infinity, although I hope nobody's using an infinite amount of data, the rules change, right? We go from a nice flat line to a sloped line, and so the rule changes depending on what the input. So as long as I keep my data between 0 and 15 gig, I'm going to pay this flat rate as my rule. But as soon as I pass 15 gig, 15.1, 15.2, 16, 20, 30, whatever the case might be, the rule that I'm going to use to pay, right, will be this rule here. So the change in rule based off of the input given. Another famous one is our income taxes. Okay, I know this isn't tax season yet, but this rule definitely changes because, and again, I'm oversimplifying this like crazy. There's actually several different tax brackets, but the idea is if my income, right, is between 0 and let's just throw $40,000 out there. So if my income is anywhere between 0 and 40,000, the taxes that I owe, right, are 0. After all we pay taxes, but what I owe is 0, right, and so I get money back. But if we go past 40,000, let's say to 100,000, just to throw a number out there, then my tax rate, I have to basically pay, let's say 10%. Let's call it income I have to pay 10% of whatever that income was. So automatically you see, right, depending on which tax bracket I'm in, or in essence what domain part I'm in, the rule changes. So if my family stays between an income of 0 to 40 grand, my tax liability is 0. If I start to earn more money and I go anywhere between 40 and 100 grand, then I got to pay 10% in taxes. It's obviously much more complicated than that, but hopefully this gives you an idea. And then of course once we hit 100 grand, I think a number that we hear out there a lot is 250,000, right? So in that next tax bracket, maybe we're paying 25% of whatever my income is, and then once we get past 25,000, right, or 400,000, whatever that number is, right, we end up paying, I think the top rate right now is like 39%. And you guys can probably correct me, but again, I'm not trying to make this a political discussion or, let's, talk, but it's just for our situation, you can see that the rule changes depending on what input's given. So if I'm in this tax bracket, I'm paying 0 in taxes, or I'm obligated to pay 0 in taxes. If I'm in this tax bracket, I pay 10% of what I've earned. If I'm in this tax bracket, I pay 25% of what I earn. And if I'm in this one, I pay 39%. So the rule changes depending on the bracket that we're in. So that's a classic situation. So let me build on that, right? So there's kind of a story and an idea, but here's what piecewise functions look like, right? So visually, I kind of gave you an idea here, but you can see, right, the domain is basically broken up in pieces. So on this first stretch, we're starting at -7 and coming up to 1, and on that stretch, again, if you think in terms of functions and lines, the slope is negative. So we're going to have something like a negative mx plus b. As a matter of fact, we can even see that b if I wanted to be more descriptive. So my rule, I would use this equation on the line if I was in that part of my domain. Of course, over here, what ends up happening is we're starting at 1 but not including it and going all the way to 6. And now, right, I have a positive sloping. As a matter of fact, let me call that capital B and capital M just to be different from down here. So my rule changes depending on what part of the domain that I'm in. And same thing over here, right? For those who might have taken trig, right, we're basically looking at maybe a sine or a cosine function here. And so from -6 all the way to about 4, right, we're basically a cosine or a sine function, right, that's down here. And we're not going to learn about these. That's for another class, but I just want to kind of get you used to that because I know some of you are going there. And then, of course, if our domain's here, right, starting at about 4 and going to infinity, we're now on this line, something y equals mx plus b. So again, the rule changes depending on what part of the domain that I'm at. And usually what ends up happening in piecewise functions, you notice there's some sort of a break in the graph. Even in my data usage, in this crazy one and this crazy one, there usually is some break in the graph where we transition from one part of the domain to the other part of the domain. And one last item I'll mention here is we got to make sure, right, that at those junctures where there's a break in the domain, we have to make sure that one's closed and one's open because we want to continue to be a function, right, one thing in, one thing out. So if I was to allow myself to be closed here, we no longer are a function. So when we do have breaks, something should be open and something should be closed. So you see that here, and I think you also see it there. So there's your introduction to a piecewise function, what they represent, how they work, right, what they look like. And now what we need to do is go do some more homework problems where we kind of look at those piecewise functions, all right? And we'll do that. We're already 8 minutes into this, so I'll start doing that in another video coming shortly.